Our standards development procedures are under ANSI rules, the American National Standards Institute for writing standards. And this is a kind of an umbrella group that oversees hundreds of standards, thousands of standards in all kinds of industries, everything. And they have a policy that standards should be reviewed on a minimum of a 5-year cycle. So if there has been no activity on a standard at all, once every 5 years, we're obligated to at least pull the standard up and say, well, let's go through it. Is there anything we should change, need to change, want to change? Anybody who has a concern or a recommendation or a proposal for a change to a standard can present it at any time. Merely making the recommendation does not guarantee it's going to get into the standard. Okay, the scope. The scope is a very important section of any standard or accepted practice, and many times you'll spend a disproportionate amount of time working on the scope. The scope is an extremely important part of the document because it amplifies on what the title of the document is and how it is separated from other equipment that you may come across. It's important within the scope that you build a box around the equipment so that you know these are the boundaries at which we're covering. If it's outside of the box, it's not covered by the 3A standard. So in most cases, a good example of a boundary on a piece of equipment like the pump, the boundaries are here and here, inlet and outlet. So for a pump, this gasket and this gasket aren't covered by the pump standard. They're covered by something else, but they're not covered by the pump standard, and the pipe coming off of it and the pipe going into it are not covered by the pump standard. So you build a box around it, and you identify inlets and outlets, and they may be numerous because it may include service lines, plate heat exchanger. So you want to identify where the breakpoints are. You don't want the standard for a plate heat exchanger for the heating section to go all the way back to the boiler. You don't want to have to include all that stuff, so it breaks at the fittings. A good example are membrane systems. You've got product in, you've got permeate out, you've got concentrate out, you might have diafiltration water in. So you want to make sure that you get just the equipment you want to cover by the standard. So the scope section is very important. And sometimes you may want to come out and very specifically state this standard doesn't include something. We have a standard for mechanical conveyors for dry products. And if my memory serves me correctly, it's got an exclusion in there that says that this standard does not cover the conveyors coming off a bag house or a conveyor coming off a spray dryer. That standard doesn't cover those items. However, the spray drying practice can reference it because they want to use those and they don't want to rewrite all the things. But just for the mechanical conveyors, it generally was written for a freestanding conveyor. So you can include what it specifically doesn't cover. This is the boilerplate wording, so we've got you identify it that it's either standard or a practice. You identify the equipment or the system as appropriate. You might include its function, its boundaries, limits, and unit operations, processing or handling sequences. The liquid products filler standard has a nice long list of forming, containers, filling, capping, and you can include the names of equipment and unit operating processes that are in the standard, so that you want the scope to be as descriptive and clear as possible so you know exactly what the document covers. It's fairly straightforward. Difficult to write, but it's a fairly straightforward concept. Anything can be done on a standard. I mean, they're written in paper, not concrete. There are cross-references, but they're generally cross-references within the standard that you can, if we say this here, you can also find another reference for it back here in section such and such. The normative reference, generally the references are other 3A standards that may be important to the piece of equipment. Like I said, on a silo tank, you've got valves, you might have sample valves on the manway door, the personal access port, you've got a personal access port, ruptured disc on the top possibly, any number of different appurtenances on a tank. So all of those would be referenced. And once they're referenced under our new format with the normative references section, they won't show up anyplace else in the document unless there's some very special consideration that has to be done. It might be follow the personal access port standard except for such and such, whatever that might be. But if there's no special consideration, you probably won't see any other reference to that standard again. It's just listed and it's part of the standard. So if you run across those components, you need to refer to those standards. So you're looking for the provisions of the document. They shall apply to this standard. There won't be further references in the document unless necessary to describe special considerations. And so this is a boilerplate lead-in paragraph that is on the normative reference section. So like I said, you may find examples of storage tanks, pumps, homogenizers, anything that's pertinent to that particular standard should be listed. The silo tank will probably reference the air under pressure for air agitation. Most equipment that has lines associated with it will have a cross-reference to the product solution pipelines and cleaning systems requirements. And again, remember that 3A standards are not written just for inspectors. They are also written for the users, and they are also written for the fabricators. So there are cross-references that are important to them as well. So you will have cross-references back to iron and steel requirements and where they can find the necessary information. There are cross-references to welding for the welding of stainless steel tubes and pipe systems. 3A worked in conjunction with AWS, the American Welding Society, to develop a way to evaluate sanitary welds in pipelines. So there are a number of welding requirements. Many times you may not have access to these in your day-to-day inspection work, but they are important to the fabricators, they are important to the users on occasion to solve and adjudicate when disputes arise. And so, if somebody says, well, this isn't 316 stainless, and it says it should be 316. Well, you've got the source document that you can go back to and determine, well, is it or isn't it? And there are normative references, Code of Federal Regulations, Food and Drug, Title 21. We use quite a few references for plastic and rubber materials, and so this is the document where that can be found. There are any number of references in 3A documents back to your pasteurized milk ordinance. So the documents all kind of work in concert with each other. Our main goal is to support public health and the application of public health principles into the fabrication and design of processing equipment. So there's a lot of different cross-references. The Format and Style Manual has quite a long list of various normative references, but they won't all show up in every document. All of these references and things are available online at the 3A website. Okay, the next section is the definitions section that usually shows up. This is where terms are defined. They are very important to the document if they're specialized terms. We're not going to review all of the definitions because there's 40 or so of them in but we're going to hit some of the more interesting ones, or ones that may be of more interest to you folks. But they define special or unusual terms used in the document so that everybody's speaking the same language. Definitions that are not used in the document shouldn't be included. The definitions section isn't intended to be an educational document of, what is CIP cleaning if you don't use CIP cleaning on this particular piece of equipment. We only want the terms of the standard in the document as appropriate. If you come across something new that you want to define, it can be created and added into the definition section. Oftentimes, even the name of the equipment in the title is a defined term under the definition so that everybody knows exactly what you're talking about. One of the most commonly used definitions, it's in almost all standards, is the adhesive or cohesive forces holding materials together. And again, this definition excludes press and shrink fits. That's a mechanical type of juncture. The adhesive obviously is pretty self-explanatory. You're using a glue of some type to hold the component together. The cohesive forces is in there to accommodate the bond that is created in plating, electroplating, chrome plating, if there's chrome plating on a piece of equipment. So it's either adhesive or the cohesive forces, but not press or shrink fits. They're defined separately, and they're also defined, or the parameters for them are in the fabrication sections of the document, and you will find a normative reference, generally. If press fits are permitted for the equipment, there will be a normative reference back to the machinery's handbook, which provides the technical aspects of how to form a proper press fit. Tolerances, dimensions, round object into a round hole, how much bigger, smaller they have to be, not square into a square hole, those things. Just recently, in one of the more recent updates to the format and style manual, we developed this new definition for a mechanical force seal. And the mechanical force seal is a very special type of press fit that is engineered with very specific geometrical shapes of both the groove and the gasket material that are pressed into the material. So as it shows, that it's established between a flexible rubber or rubber-like or plastic material when pressed into a special groove in metal or glass component using a combination of compression pressures and the unique geometrical shapes of the joined materials to create a tight seal. This is a very special force fit, special type of gaskets that's not intended for daily disassembly, for cleaning or for inspection, because you essentially destroy it. But it's very common. You'll find them on valve plugs, a number of rising stem compression type valves. You'll see these, and you've been inspecting these for many years because they're very common on lots of different types of valves. So it was, as we got into the updates of some of the valve standards, we had to develop this mechanical force seal definition, primarily to get this point across that a mechanically forced seal is not intended for routine disassembly and cleaning. that it wasn't like a normal O-ring. Once you started digging around in there with your little screwdriver, it was shot. You had to have a special way of getting a new seal put back in there. You can't put it in by hand. It's not a finger-tight seal. It takes a lot more compression and pressure to get it inside. So it became